Welcome to Lessons Learned from Scaling Infrastructure as Code. My story started when I was using some infrastructure as code tool. In this case, it was Terraform. In the past, it was CloudFormation. But the idea is that we started using these tools in order to provision infrastructure almost as if it was code. It was awesome. We could create these resources using version control, push the changes, test them. It was a really great way to control changes to infrastructure and avoid breaking all of these resources. But as time went on, we encountered a bit of a problem. Other teams started using infrastructure as code tool. And well, we had a couple issues. The first was that we couldn't figure out who was making changes anymore. Second, we couldn't figure out conflicting changes. So if we had some kind of merge conflict, we'd have to go through and figure out what kind of configuration changed and how someone else's change might accidentally override someone else's. So it was a bit of a mess at the time, and we had to sort out a bit of this problem. And actually, it occurred to me, this is a problem with scaling infrastructure as code. It's not really about the tool itself, it's about how we actually collaborate using all of these tools and practices. So I compiled a bunch of content and researched it a little further. Eventually, I became a developer advocate for HashiCorp in Terraform, which is an open source infrastructure as code tool. If you have any questions about Terraform or the presentation today, you're welcome to reach out to me. I will say this is a bit of an advanced talk, so if you're not so familiar with Terraform, that's all right. You can still take some of these practices and apply them to your infrastructure as code practice. So today, I'm going to talk about 4 challenges in 4 categories. The first is development, second delivery, third is security, and fourth is cost. We'll go at it from a bit of a higher level view, and we'll dive down a little bit further. If you have any questions about the details regarding each of these challenges and their solutions, you can always reach out to me for more information. So let's start with our first set of challenges with respect to development. This happens because when you have a lot of people making changes and pushing changes to infrastructure as code, well, those changes break infrastructure. And the more you have changes, the more likely that your infrastructure will break from them. That's just what happens. So your solution has to revolve around empowering every team to responsibly contribute to infrastructure. This means that you can't prevent every change from breaking something, but what you can do is minimize how those changes impact your overall infrastructure system and make sure that every team member who does contribute is doing this responsibly. So the first technique that I have for solving this challenge is standardizing infrastructure resources. In the case of Terraform, we use something called modules. And modules are what you can do to share infrastructure configuration between teams. What you do in modules is standardize the specific configuration you want so that way it is reliable, secure, and functional. In this case, I have a module that creates an application in Amazon, for example. And what I can do is I can use that module self-service, create it with a specific version, and pass in and customize the kinds of parameters I want for that application. It's really powerful to use infrastructure modules as long as you set the opinionated defaults and you allow collaboration in the form of pull requests or some kind of system where you can admit changes and approve them. Third is apply that testing strategy to modules. It's important to test modules for function, otherwise it might break someone else's configuration. So make sure you implement some kind of testing strategy. And most importantly, version modules. This goes without saying that you should tend to version dependencies, but in the early formulation of Terraform, a lot of people didn't pin versions for the Terraform modules they were using. And as a result, if they made changes to a module and then upgraded their configuration, it broke everything. So version your modules. When it comes to infrastructure configuration, so this means that you're using the modules in your configuration, try to keep them small. If you have a large infrastructure configuration, you'll have a lot of sequenced changes, and it's really hard to make the changes without impacting something else. So try to minimize the blast radius of changes. Understand the impact of making one change to one resource and how that might affect your entire system. Use immutability to roll forward. Infrastructure as code favors this concept of immutability. The idea is that rather than update a resource in place, you create an entirely new one with the correct configuration and you replace it. So use immutability to roll forward changes rather than rolling back. Finally, use version control when you can. The problem with infrastructure is we tend to make these out of band or like manual changes, and you can't reconcile them with the desired state that you want when it comes to infrastructure as code. So as long as you're using version control to make those changes, you get a perfect sequence of changes instead of going these like out of band, maybe sort of potentially breaking changes that you don't know about. As a note, a lot of people tell me, Rosemary, I started with a monorepo or a single repository with all my Terraform configuration. But now something's not working anymore. My build tool can't handle it. So I will say most people who start with a monorepo for infrastructure as code tend to refactor to a multi-repository model. The reason why is that build tools do not necessarily handle a Terraform monorepo or infrastructure as code monorepo well. Your CI framework has to recursively check every directory for changes, which gets very tedious when you have hundreds of modules and thousands of configurations. So in general, unless your build tool can handle the volume of checks that it needs to make per directory in a monorepo, you'll tend to refactor to a multi-repository. The second technique I have for managing the challenge of development is to decouple dependencies within your infrastructure as code. It's a little counterintuitive because I'm showing a domain-specific language in the form of Terraform, right? It's not traditional code. But if you think about it this way, you should be able to retrieve information about your infrastructure using the infrastructure API. This is critical to when you need to collect different resources and organize how they're being changed. If you can decouple the information that they need about each other, you can make changes independently without affecting other upstream resources. So in this case, I am retrieving the identifier of the Kubernetes cluster from AWS. And I'm doing this by reaching out to the AWS API using Terraform data source. There are a couple different ways that you can do dependency injection, which is what this technique is appropriately called. The first is to use reference outputs stored in state. So this is something like put it in state and then go back and reference it in another module or in another configuration. The second way to do this is to use the infrastructure API, which is the example I showed. The third is to store and reference it from a configuration manager. As you do this, make sure that any of these abstraction layers you're using to store the information about the dependency, whether it be an identifier, a configuration, an IP address, etc., make sure it's just being updated. So that way, any modules or any configurations that depend on that identifier are always updated. As a note, multiple infrastructure providers or environments will require additional abstraction. I have to always recognize the fact that Terraform is powerful, but it's not a uniform data model across all infrastructure providers. So for example, when you talk about a server in Amazon or a server in Azure, it's not the same. So if you do want a single data model for all your infrastructure, you will have to add that abstraction and automation yourself. Furthermore, while Terraform and other infrastructure as code tools come with sort of environment structures, so for example, they'll help you duplicate code across environments, you do need additional automation to provision or to add certain parameters to customize environments. So for example, you'll have to specify a dev environment a little bit differently than a prod environment, and you'll need to add a little bit of automation on your own in order to accomplish that. So the second set of challenges is delivery. Delivery is the problem of taking way too long to deploy changes. And it's important to recognize that taking a long time to deploy changes is inevitable when it comes to infrastructure. It takes a while. It could take somewhere between 2 hours to 6 days. When you think about solving this problem, you want to minimize the time from the moment you commit to the moment that change goes to production. And so when you think about the time from commit to production, there's a lot of interactions in place. If you really want to go into the deep internals of Terraform, I've put this diagram out there. The idea is that Terraform core, the binary you download as an open source tool, communicates to a plugin over RPC. That plugin communicates to a target API, whether it be your infrastructure cloud or other, over Golang, as well as some kind of client library and subsequently usually a REST API. So there's a lot of interactions in place. When you do this sequence, there's a lot of latency in between each of these steps. So the first is to download modules and plugins. So I mentioned before, it needs to communicate to these plugins over RPC, but you need to download the plugins. There's a custom binary that we've written called GoGetter that downloads these, but they download each of these modules and plugins sequentially, which means that if it takes a little bit longer, you'll end up stalling on this download command. So just keep that in mind. The ways that you can solve this is to use an internal artifact repository, so you're not subject to any kind of network latency. And the second is to cache the providers and modules on a local file system. A couple folks who do this will be able to use the get submodule add approach, so they'll use each provider and module binary as a submodule. But after about 100 submodules, this sort of breaks down. So keep in mind that you want to limit it to a few providers and a few modules. Second step is to refresh the state. Now, Terraform itself needs to know whether or not the resources actually exist, but also whether or not some of these resources are up to date in terms of configuration. This is an API call. So you can imagine this is an HTTP GET request, and it's multiple HTTP GET requests. After this stage, you also have the apply stage, which is, again, even more infrastructure API requests, except not only do you have read, you also have create and update and delete actions as well. So if you have something like 105 resources, like I do in this configuration, your changes will look something like this, a graph that you cannot review and you cannot understand. So this is a map of the dependencies between the 105 resources related to this state refresh, as well as applying these changes. And you'll recognize that there's a lot of dependencies. It's a very, very deep graph. Terraform uses a depth-first search in order to walk this graph and understand what order of operations it should use to create or update some of the resources. So what's important to recognize is that for every apply or every change that you make for a resource, it's going through 4, 5, if not more API calls each, which means that it does take time to apply and it does take time to refresh that state. And this is where most people complain when they say it takes too long to deploy to production. So how do you solve this problem? Well, the first is to enable concurrent operations. Terraform uses a parallelism command that you can enable. You can tune your infrastructure API. Most infrastructure APIs will complain that you've sort of hit a rate limit. So you can increase that rate limit, and that way you'll be able to make more API calls, for example. You'll also modularize into fewer resources. That's probably the most difficult, but also the most simplistic way to solve this problem. If you put fewer resources into the configuration, it's a faster refresh and apply because there are fewer API commands. The second is that you have fewer state locking conflicts. This is important to note because in a large configuration with lots of people making changes, Terraform locks state so that it applies changes sequentially. This is for the safety of the system. If you have a smaller configuration, other people can make changes at the same time in parallel. You don't have as many conflicts. So it's important to recognize the fewer resources you have in your configuration, the easier it is and the faster it will be to deploy these changes to production. As a general note, I get a second question following this, which is whether or not you can use continuous deployment for infrastructure as code. This means that you don't have a manual approval step for infrastructure. The thing is that infrastructure tends to have a manual approval step between peer review as well as understanding all these different conflicts that you might have with specific changes. If you have an organization that's really familiar with continuous deployment, has a bit of an error budget, and has the ability to roll forward changes, you're really confident in the way that you can fix your system, then you can go ahead and remove this manual approval step. But most folks may not be up to that kind of approach, in which case you can keep the manual approval step. Just make sure that you approve as quickly as possible when these changes go to production. The more you batch your changes, the more likely some kind of change conflict will happen. So the third set of challenges you'll encounter as you scale infrastructure as code is security. Security often relates to the problem of misconfiguration. If you don't configure your infrastructure correctly, it could compromise your security. For example, if you leave an open network policy, then someone could exploit your network. The idea is that you can use infrastructure as code to enforce security. For example, in the case of that firewall rule that I mentioned where I left my network open, I have a rule here using HashiCorp Sentinel, which is part of Managed Terraform Cloud, And the idea is that this rule will determine whether or not the firewall is too permissive. So the rule may start from 000 and end at 255, 255, 255, 255. But the important thing is that this rule is going to check whether or not that rule is within that range. And if it is, it means that it's too permissive. You need to restrict it to very specific IP addresses. And this prevents folks from exploiting that system, right? You're not going to have an external person come in and use the database for some reason. So you can add this as sort of like a unit test, or as I call it, static analysis. So what you'll do is standardize some of these tests for static analysis of infrastructure as code. This means you're defining secure standards and defaults. I mentioned before that modules offer opinionated defaults. These modules should also offer secure opinionated defaults. So if you add that in place, you're in a great place to make sure you're baking in security into your system. Second, enforce changes through infrastructure as code. It's easy to make an out-of-band change because you're making some kind of emergency change, for example. So you might go into the console, click, and fix something. But you want to make sure you backport them to infrastructure as code so that you can audit those changes as well. From a security standpoint, it's important to make sure that you set the access of the system so that you're always making the changes through version control so you can identify anyone who's in the system and not an authorized user. The third is enabling dynamic analysis of infrastructure has become more of a focus recently. In the case of infrastructure as code, we've talked a lot about drift detection within the space. The idea is that we need to know whether or not an active resource has drifted from the desired state. And this is a really good indicator if maybe something has gone wrong, there's a one-off kind of configuration, or perhaps some kind of insecure configuration going on. So drift detection is one important thing, and more recently we've been talking about automated reconciliation. So the idea is that we're not just analyzing live infrastructure and making sure that it doesn't have kind of drift in it, we're also reconciling it automatically. There's a number of tools that are able to help with that loop. As a note, of course, in security, make sure you control access to infrastructure, not just for anybody who's creating the infrastructure, but also for the infrastructure as code tool. If Terraform doesn't need to create the database, don't give Terraform the permissions to create the database, right? And more importantly, infrastructure as code tools try their best to secure sensitive information, but try securing the secrets outside of infrastructure as code. At the very least, you're not storing that sensitive information and you're managing it separately and rotating those secrets outside of, let's say, version control as well as infrastructure as code state. Finally, the last set of challenges you'll encounter is cost. Cost tends to encounter this sort of situation where we realize we want to create all these infrastructure resources, we get really enthusiastic, and then we realize we could be more efficient with our infrastructure. It's really easy to provision a bunch of servers or a bunch of databases with infrastructure as code, but then you realize you haven't really been that efficient with them. And then you get your cloud bill back and you're like very surprised that you've been charged this much for the infrastructure you've created. So what you can do as you scale your infrastructure as code is apply cost management techniques. There are a couple ways to do this. The first is similar to the security space where you're adding some kind of static analysis. In this case, maybe I'll have another test that says, check that the CPU size is less than or equal to 32. If you're working in a system where you expect to horizontally scale, you probably don't want your CPU size necessarily at 32. You may want them smaller, for example. So make sure you add some tests for cost compliance if cost is a really big concern. The second is that you can also enforce tags or do some kind of reboot schedule. If you enforce tags, this allows you to set an expiration date and standardize and identify if there's maybe untagged resources that aren't supposed to exist. So you can also set the resource type, size, and reservation as well. Part of setting the type and size and reservation is to just take advantage of off-peak hours or perhaps, as I mentioned before, horizontally scaling a distributed system. But you can also check if auto-scaling is enabled. Auto-scaling means that you'll increase the resources based on a metric or decrease them based on the similar metric. And this will allow you to manage the costs more effectively. As a note, I don't go through this into too much detail, but testing in production can eliminate some development environments and thus some cost, right? So the idea of testing in production is to use feature flagging or blue-green deployments so that you can remove long-lived development environments. And this is one technique that does work. The downside is that if you create a completely duplicate environment in production and you expect to test it for about a month or two, you're going to be paying for both those environments. So it's not that the cost itself is necessarily going to be fully eliminated. You do have to pay for two environments for some period of time. There's perhaps a small cost reduction as a result. So if you do decide to do some kind of testing and production approach, evaluate what kind of cost it does have, because sometimes creating whole new environments on demand ends up costing more than just keeping a long-lived development environment. So today we went through these 4 sets of challenges with respect to development, delivery, security, and cost with scaling infrastructure as code. I know that it's a lot of information. As you're going through your company and your team and trying to figure out how you can scale your infrastructure as code, recognize that it's about scaling the collaboration and the process. It's less about the tools themselves. So the tools are available, and there are ways that you can optimize the tools for better performance. But at the end of the day, to make the most of the tools, the best way that you can address some of these challenges is to look at some of the ways you're collaborating, working, and pushing changes using infrastructure as code in the first place. I appreciate you listening today. If you have any questions, you can always reach out to me, and you'll find the slides at this link later.